Assalamualaikum. My name is Shahrul SABRIE, matric number DE 2098. For introduction, an inverter is a power electric device that transforms electricity from one form to another, such as the direct current to alternating current at a desired frequency and voltage output. This is based on the power supply source as well as the applicable architecture in the power circuit. As a result, it's classified as voltage source inverter VSI and also current source inverter CSI. A variety of variables may be used to categorize inverters. There are two types, the single phase and also the three-phase inverters. There are many methods for controlling the AC output voltage. The first one is the single pulse width modulation. Other than that, there are multiple pulse width modulation, and also the lastly is the sinusoidal pulse width modulation, the SPWM, which is the one that we will present about. For this project, there are three objectives that will need to be achieved. The first one is to construct a simulation using appropriate software to evaluate the power converter performance. The second one is to analyze the various types of power converters characteristic based on output requirement. And the third one is to respond the issues raised in power electronic applications.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMAD bin AZAHARI. My nomenclature is DE200067, and now I will present about the methodology and the conclusion for the project. So for the part methodology, the first chart of the system development, which resembles the flow of the SPWM three-phase inverter model from the start to the end. Because of the system is a closed loop, there is an input from THD which must be less than 7%. As a result, only a few steps are required to construct the MATLAB simulate. So first, we need to do the research that related to the project, and next we need to seek switch inverter topology. We proceed for choosing the switching schemes and design the circuit simulation and make a discussion. After that, we running the simulation and we must get the THD less than 7% and achieve the smooth sine graph.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ALIMIN bin Muhammad PAUZI. My number metric is DE 2071, and this is our circuit for our assignment, which is we use the SPWM inverter and switcher. From the circuit, we need to add filter to make sure our THD is below 7%. With that, we get the value of THD is above that, which is 30% something. And to reduce our THD value, to make sure our THD value get below 70%, we add the inductor and capacitor. So for the capacitor value is 35 milliH, and for the inductor, we put the value 330 microfarad. So as you can see, after we add the capacitor and inductor, we got the graph current in the sine wave, in the beautiful sine wave form. Also, at the voltage graph, we also get the sine wave also with the good form of the graph. So after that, to prove that our our THD value is below than 7%, we open the FFT window, and for this scope data one is referred to the current sine wave, and we put this time starting 0.2, number of cycle 5, C is 50, and maximum frequency is 500 Hz. And then we stay and complete FFT. So as you can see, the value of our THD for the current is 0.3%, which is matching with our requirement. So for the voltage, same 0.2, number cycle 5, fundamental frequency 50 Hz and maximum frequency is 500 Hz, and we compute it. Also, we get the value THD below than 7%, which is we got the 0.63%. So based on the result from the value THD, we got the THD is below 7% from both sides, voltage and current, and the form of the graph, current and voltage in sine wave. I can conclude that our group circuit is in the stable condition. That's all from me.
For the manual calculation, the input voltage need to be up to 1000 VDC max, and for the resistance is 14 ohm, and then for the inductance is 0.3 millihenry. Given the line to line voltage needs to be 415 VAC, and the frequency is 50 Hz, and the total for harmonic distortion for both voltage and current need to be less than 7%. And then we first will calculate the output fundamental. We get the value of 900 VRMS, and then we will calculate the output power, which we will get 71,428.6 watt. Then we will calculate the peak current for each transistor, which we get the value of 35.71 ampere. And then for the reverse voltage, we get the result of for 2000 volt. Then we calculate the THD with the input voltage and also the output fundamental, and we will get the THD over 48%. And for that, it needs to be less than 7%. Then we calculate the distortion factor. For the distortion factor, after calculating it, we got the value of 3.8%. Then from there, we calculate the filter calculation, and we get the value of THD 0.62%, and from the simulation is closer to 0.
Assalamualaikum warahmatullahi wabarakatuh. My name is SYAQIR bin SAFARUDIN. My number metric is DE200107. So now I will present for result and discussion. Okay, first we can see that the circuit diagram before add filter into the circuit. Okay, then we got the graph for voltage and current. So the outcome in unstable condition for voltage and current, which is we got the peak voltage and peak current. Okay, for the peak voltage we got 663 volt and peak current is 555 ampere. Okay, next, the THD for both voltage and current output is above than 7%. So here we can see that the average THD output for voltage is 31.09%. Then the average THD for output for current is 30.49%. Then so it does not fit with the requirement that it is to get THD below 7%. Okay, now the circuit diagram after add filter into the circuit. Okay, here we need to installing the filter which are inductor and capacitor, and then we need to set the inductor value that is 35 millihenry, and for the capacitor value is 330 microfarad. Okay, after that we got the output graph for current and voltage. Okay, the output signal for both is in sine wave condition, which is after installing the filter into the circuit. So we can see that it become more stable and smooth sine wave compared to the graph before the filter addition, which is the peak voltage value become higher. So we got the peak current and peak voltage 585 ampere and 820 volt. Okay, lastly we got the output graph for the voltage and current for each phase become more smooth after the filter was added into the circuit. Then the THD for both voltage and current output is below than 7%. We got the average THD output for voltage is 0.63%, and then the average THD output for the current is 0.62%. So it is fit with the requirement that is to get THD below 7%. So that's all from me. Thank you.
Okay, now I'll proceed for part conclusion. Finally, this project is designed to provide students with an opportunity to study the power electronic converter in order to create a three-phase inverter system utilizing any software. By completing this project, students will be able to create the fundamental operating system for a three-phase inverter system with RL load using MATLAB. The design of the circuit can be perfectly run in MATLAB with the appropriate selection of switching scheme from the list. In MATLAB, the output value with no filter addition results in a large total harmonic distortion. As a result, a filter must be added to the system to ensure that the overall harmonic distortion for the voltage and current output is less than 7% as specified by the project. When the total harmonic distortion is less than 7%, the output waveform is a perfect sine wave, as opposed to the when no filter is used. As a result, we may deduce that the overall harmonic distortion must be reduced in order to achieve the desired output value for the inverter system. Finally, it demonstrates that the students can solve the problem using the knowledge gained in the class for a three-phase inverter system. Thank you.